Alright guys, welcome back to our final Math Notes video for Chapter 9. This is 9.2.4, General Equations of the Sine Function. So right off the bat, I'm going to tell you that this general equation is slightly different than the one we've talked about in class. We'll talk about what that difference means and how we can deal with it. So this is the general equation that the book gives you. Y equals a sine b times x minus h plus k. And at first glance, that looks really similar to what I gave you in class, which was y equals a sine bx minus h plus k. But that bracket and parentheses are important, and we're going to talk about why that is and what difference that makes. Before we do, we're going to follow through with what they have here. So we have our sine graph given to us. This thing has been shifted and moved around. And just some definitions here. Cycle of a periodic function is a connected piece of the graph of the function that is one complete repetition of the pattern. So we're going to go from a starting point to an ending point where those things repeat again. So if we look at this, would be one cycle, one period, one wavelength of the sine graph, okay? You'll notice that after this point, it starts to repeat the same pattern that we saw before to plus or minus infinity. The amplitude is half of the vertical distance between the highest and lowest points, and it's called A. I'm going to say that it is the distance from the center line of the graph. So we have that center line that goes to the center of our function, and our amplitude goes from the center line to the peak, or from the center line to the trough. Having some trouble with the smartboard today. Hopefully that will resolve itself. Okay. The period is the horizontal length of one complete cycle, and it's labeled P on the graph. And we've talked about in class how we're going to use the word period in here, although in other applications, wavelength may be more appropriate for a description of a cycle length. In physics, if you're talking about an actual length being your x-axis, you use wavelength. If you're talking about time, you use period. And we're going to use period here as our theta. The number of periods in 2 pi is b. The vertical shift is h. Sorry, the horizontal shift is h. And the vertical shift is k. And the midline is y equals k. So the real difference here in the two equations that I pointed out is going to be right here on the horizontal shift being h. So what they've done, the difference between the bottom equation and the top equation, is they have factored the b term out of the x minus h, and we'll talk about what that means again through an example on the next slide. So from this point on, I'm going to use this equation, okay? Y equals a sine parentheses b times x minus h plus k, where we have not factored the b term out. And we're going to write down these steps for graphing sine and cosine. I would suggest you go ahead and pause this right now and write these down, and we'll do a couple examples on the next slide. Okay, should be back from the pause. I have those steps written out to the left here just so we can reference them as we go. And I've got two graphs, a sine graph in red and a cosine graph in blue that we are going to do here. And I've got a bunch of these dotted lines sitting around for some reason, and you'll see why those are there in just a second. Okay, so the first thing we look at is the red graph. It says y equals 3 sine 2x minus pi plus 1. So we've got a bunch of different shifts going on here. We know that if we were to graph just the graph of y equals sine x, that we would have a 0 here, a 0 at 2 pi, a 0 at pi. We would have a peak at pi over 2, and we would have a trough at 3 pi over 2. We would be able to connect those with a smooth wave like that. So that's our mother function for this. And we're going to shift that around in a variety of ways with that new equation. So the first thing I'm going to graph, our first step there, is to graph the new center line. When we graph the new center line of the graph, we're going to look at the k value. In this case, the k value is 1. So this graph is going to shift up by 1. And I'm going to put the center line right there. And that's the first dotted line I'm going to pull up here. So we have a center line right there at k equals 1. Then I want to graph the upper and lower boundaries based on the a value. The a value, remember, is the distance from the center line to the peak and the trough. So our a value here is 3. So our upper boundary is going to be 3 units above the center line, and our lower boundary is going to be 3 units below our center line. So if we say 1 plus 3, that'll get us to 4. 1 minus 3 will get us to -2. So those are where our upper and lower boundaries are. We have our upper at y equals 4, and our lower at y equals -2. Now we need to put some left and right boundaries on our graph. To find the period, the first thing we're going to do is take 2 pi and divide it by b. In this case, my b term is 2. So when I do 2 pi divided by b, I get 2 pi divided by 2, which is just pi. So that means it's going to take a distance of pi to complete one cycle. If this had not been shifted at all, then I could say that it would be between here and here. But this has been shifted left and right. Now, to find the starting point or the amount of the left-right shift, what I'm going to have us do is set the equation in the parentheses, the whole thing, equal to 0. So we're going to say 2x minus pi equals 0. Got my dog making a little cameo there. We're going to set that whole parentheses equal to 0, so then we're going to have 2x equals pi, or x equals pi over 2. So we've shifted pi over 2 to the right, which means that my starting value, instead of being here at x equals 0, is instead at x equals pi over 2. And then since we know our period is is pi now, all we have to do is add pi to pi over 2. So if we add 1 pi to half a pi, we get 1.5 pi, or 3 over 2 pi. So this is the space that we need to fit our sine graph into. And we're ready to go. So we know we have a starting value 0 here, and in the middle we have a peak halfway between those two and a trough halfway between those two. I connect them with a smooth line, and that is one cycle or one period of this new shifted function. And if I wanted to fill it out for the rest of the graph, I could come over here. We need a period of 1 pi, so we have 1 pi distance there. Make another 0, 0, 0, peak there, trough there. Connect the dots. And just keep doing that until we've graphed as much as we want to here. All right, so you'll notice though that our horizontal shift was not pi. It was instead pi over 2. If we had done it the way that CPM has it written out, and we had factored a 2 out at the very beginning, then we could have seen our horizontal shift more directly. So if we had, let's zoom in here and see if I can squeeze it in. If I were to factor a 2 out of this middle part, I would have 3 times sine bracket 2. So 2x divided by 2 would be x, minus pi divided by 2 would be pi over 2 plus 1. And if I rewrite the equation like that, then now I can see directly that my shift is going to be pi over 2 to the right. And it gets me into the same place that I was before, with the starting value here at pi over 2, because we moved pi over 2 to the right. We still need to find the period in order to find the ending value, which is 3 pi over 2. We have the midpoint again right there in the middle. our peak and our trough, connect those, and we have our cycle. So let's take a look at the cosine, which is going to be done exactly the same, except that we have a different mother function. So with the cosine, remember that we have, our highest value there at 0, then at the end at 2 pi, our lowest value at pi, and we do something like that for our mother function for cosine. So now we're going to translate that, move it around, transform it, see what we get. So if we were to rewrite this using the method that CPM uses, we could say y equals, remember our amplitude here is 1, even though it's not listed, I'm going to write it in. Y equals 1 cosine, factor out the 0.5. When I do pi divided by 0.5, when you divide by 1/2, that's the same as multiplying by 2. So those two would be equivalent expressions. I need another parentheses in there. Okay, those two would be equivalent expressions. Let's go ahead and solve it out now. So we're going to put our center line at -3 because that's our k value. So we're right here at -3. We're going to set our upper bound based off of our a values. That's the distance from the center line to the peak. So we're right there at -2. We're going to have our lower bound at 1 below the center line. So that's going to be at -4. Now we need to find our starting values. So a couple ways to do that. If we go with this method, we can see that we have shifted 2 pi to the left, and that our starting value would be at -2 pi. If we go with the original equation and we set it equal to 0, then we have 0.5x plus pi equals 0. We subtract pi from each side. Divide by 0.5. And we get x equals -2 pi, indicating that our graph has shifted 2 pi to the left. So again, either way is fine as long as you pay attention to how the equation is written and adjust your strategy accordingly. And as far as our period is going to be 2 pi divided by b, so that's 2 pi divided by 0.5, which equals 4 pi. So this is actually stretched. Instead of taking 2 pi to complete a cycle, it's now going to take 4 pi, which means it's going to take our whole graph from -2 pi all the way to +2 pi. We're still going to have our peak at the left and right edge. We're going to have a trough in the middle. Between those two, we have our zeros. Just like on the mother function, it's just been elongated. And then we can connect those with a smooth curve, something like that. And that would be a graph of our new function. All right, guys.